Hey everyone, so we are continuing with our multiplying and dividing with rationals. We're going to actually start with number 5 here with multiplying. And really I just want to go back with what are the steps. Remember, we want to factor every numerator and denominator as possible. Once we have done, we will divide out any factors that are common to both, and we'll leave our final answer in factor form. So make sure simplified form, that means no common factors other than 1. Okay, so what I'm going to have you guys try here is I'm going to have you go ahead, pause the video, and factor everything that you can for number 5. So go ahead and do that. Okay, let's see what you got for your factorization. So here's what we should have gotten. So notice even in the numerator, we can factor it because there's a greatest common factor. So don't forget, every single time, ask yourself, is there a GCF? Okay, so our greatest common factor is 3x. Remember, when I take that out, I divide every single term by the GCF, and that's what's left over in here. So we have that. Now, what we also have to do, because it's part of our instructions, we have to state the restrictions. Remember, the restrictions are numbers that if we plug back into our denominators, that will give us 0. And remember, anytime we have 0 in that denominator, it makes it undefined. So that's what I want you guys to do. So pause the video and find the restrictions for this problem. Okay, let's see what you guys got for. So we should set everything with that variable not equal to 0. So x can't equal -5, 1, or 0. And we plug any of those numbers back into our x, that would give us 0 in the denominator, make this undefined. Okay, now from this point, we need to cancel some stuff. Now, before we do that, notice that one of our factors, x, is negative. We really want to make sure that all of our x's are positive. So what I'm actually going to do is I'm going to take out a negative. I'm going to put it in front of the 3x, and I'm going to rewrite this. So I divide both of the terms by negative, so that actually gives me x minus 1. Okay, so you may have noticed, hey, I need to actually take out a negative 3x, so then basically my variable x is positive. Okay, let's cancel things out. I see an x plus 5, x plus 5, x minus 1, x minus 1. I even see a 3x and a 3x. Remember, they don't have to be in the same fraction in order to cancel. So now all I am left with in the numerator is a negative in this x minus 4. And in the denominator, I canceled everything out. So remember, we leave everything in factor form, so this would be our final answer. Okay, let's look at number 6. So we have x plus 2 over x cubed minus 27 times x squared plus 3x plus 9. Now, in order for us to do this, I'm actually going to make this x squared plus 3x plus 9, put it over 1 to make it a fraction. Here's what I want you guys to do. I want you guys to pause the video and go ahead and see what you can factor. So go ahead and do that. Okay, here's what you should have gotten. Now, you may have noticed, what, this x cubed minus 27? Well, this is what we call our difference of cubes. So remember our difference in sum of cubes. This is what you guys learn in your polynomials unit. Okay. So basically, if it's a difference of cubes, we would do a minus b. Then we have a squared plus ab plus b squared. Or if it is a sum of cubes, it's really the same thing. It's just your signs change. Remember, SOAP. So then we have a plus b times a squared minus ab plus b squared. So remember the idea of SOAP. We have the same sign, opposite sign, and then the last one is always positive. So you guys learned that as stated in the polynomials unit. So we have x cubed minus 27. I'll go over this quickly. So remember, we take the cube root of each term. So our a would be, in this case, just x or 1x. Our b, so the cube root of 27 is 3. We take x and 3 and we plug it into here. So notice when we plug this in, so you may have to pause the video to write all of this information down if you kind of forgotten some information. So go ahead and do that. So using x and 3, I plugged it into my formula. So I have x minus 3, then I squared x, then I multiplied my 3x and squared the 3. So that gave me 9. Okay, now in this case, really like on a homework, you won't have to find a restriction of this x squared plus 3x plus 9 because that makes it very difficult. We can find the restriction of x minus 3, so we'll just do that really quick. So I take x minus 3, I'm going to set it not equal to 0. You will not have something like this where they will ask you to find the restriction. So don't worry if this is a little bit too complicated. You'll really have something like number 5 or anything like number 3 and 4, or as well as number 1 and 2. So it'll be kind of those simple there. Okay, now we cancel. The really only thing we can cancel is this x squared plus 3x plus 9, so cancel those out. So now we're just left with, on the top, x plus 2, and then x minus 3 in the denominator. Now remember, because we have plus and minus here, I cannot vertically cancel out my x's. If this was being multiplied like 2x and 3x, then yes, I can do that. But with plus and minus, cannot cancel the x's vertically. Okay, go ahead. I'm going to have you guys watch the next video, which is going to be over dividing with our polynomials.